Let me show you what's going on back here. Steve and I moved this table out the other day so I can get back here and start wiring. And I hung a lamp up there so the video turns out better and I can see what I'm doing. This will give me an opportunity to connect these to the wall. It'll help them from moving like this when they're running. So I've got my tripods and stuff like that ready for making videos. This thing's sitting here waiting to go down here. And I have an idea. I'm going to take this thermometer sensor that goes to this, put it inside this case, and then monitor the temperature with this indoor-outdoor thermometer. And make sure that it's not getting too hot in there with the lid on, you know. So anyway, that's what I'm up to. Start wiring this thing here shortly. Yep. Get my motor coupler on there. This is my motor coupler. It's a hose, reinforced fuel line hose with 2 clamps. And then it sticks into the motor, you know, like this. Simple. Our bearing on our threaded rod with a captive nut type deal. The threaded rod, our anti-backlash nut made out of Delrin, comes on through and ends up at the motor. I'll show you the coupling. That's it. Must be supper time for Shadow. So this one's ready to go. Now this wire going to this wire, this is from the micro switch. It's not a good idea to put it with the wire. But I've had this machine running before and didn't experience any interference. So let's just try it. It's already set up to go that way. We'll see. For now, I'm just going to pop in that heat sensor there that goes to this, and I can monitor the temperature right near that heat sink. And we'll take it out later. And hopefully the radio will be able to go through this metal case, you know. Yeah, we'll see. So I have the motors reattached, and all 3 motors are the same. They're 80 ounce, and it's fairly small size motor for the size of machine. But I built this originally with these motors, and it worked fairly well. So what I thought I would do is go ahead and hook these motors back up the way they were and run it for a while and see where I need more power. And this will give you an idea of, if you're building a machine, what size of motors will you need. I can tell you from experimenting with this machine, the most powerful motor that's needed is on the spindle to move this up and down. And it will probably ring true with this too. But anyway, I have the wiring hooked up for the motors. Now I'm going to hook up the sensors and continue with that. So if you guys remember this stupid box, I just drilled 2 holes in it, and I'm going to drill smaller holes through there and mount it to the wall with screws. It's the only way I can do it. I've locked myself out. Yeah, I think I can go right on through with screws. Took a chance. Looks like I scored. Good news, I didn't hit any wires. And let's see, the Z is red. So these 3 switches, actually 6 switches, share ground. You can do it. Something like that. This should be my last connection back here. Yay. Think we got the wire all finished up. Shadow wants fed. I want to explain briefly how I hooked up the micro switches. It's pretty easy, really. This is my table for my router. And if you were standing here, this lower left-hand corner is considered my home position, and I start all jobs at that position. Now the gantry overhead that has the Z, the spindle, I'll just put over here, and that goes up and down. The top of stroke, when your bit is off the material all the way as high as it can go, is considered 0, and that would be home. And then plunging into the material would be a negative direction, just so we're clear on this. So with the micro switches, I take 2 micro switches that are normally closed, and see, there's 2 varieties of micro switches. When you're not pressing them, they can be either normally closed or normally open. Normally closed would be if you're not pressing the switch, it's making a physical connection. Normally open would be the circuit is broken. So I take 2 for each X, Y, and Z, and I'm using 3 pins. I'm using pin 11, 12, and 13, and then ground is shared among all of them. So on the X, I put a micro switch here and here, and I connected them in series. So I took pin 11, let's say this is pin 11, I went into the first micro switch on this side, and then I came out of this side into this one, and then this micro switch went to ground. I'll just go like that. So if either one of these switches are tripped, it will open the circuit on pin 11. And I did the same thing for Y. I've got a micro switch here and here, and then I used pin 12 on this. So I came in on pin 12, this micro switch. I wired it in series. This went to ground. And then on the Z, same thing. I've got a micro switch here and here. I go from pin 13 into the first micro switch, out of that, back out into ground. And this is how I did the 3 sets of micro switches. So I used 3 pins, 11, 12, and 13. Now, when you wire it this way, if you open this switch or this switch, pin 13 doesn't know. If you open this one or this one, it doesn't care. It just trips, pin 13, that your circuit's open. And that's fine for limit switches, so you don't go too far and bump into things and destroy your machine. But when you're homing, you can also use these same switches as home switches. So this switch, and this switch will become my homing switches when I declare them in the setups of my ports and pins. So when this switch is bumped, that's home, home, and home. I can show you in ports and pins setup how I did that. It's pretty simple. So it's been running a few minutes there, and it's 71 inside the box and 75 in the ambient. So it's actually cooler in that box with the fan blowing on it than it is out in the open air. I'll keep an eye on it. So a good test to your wiring is to run the Roadrunner. I've showed it other times. It's a sample G-code file. And it's running pretty good right now. We're just putting it through its paces. But I had a little problem that I'll describe to you. Let me activate the limit switch and shut it off for a minute. Those limit switches were giving me a problem. If you remember when I talked about wiring this, I talked about these wire looms and how I sent the limit switch and homing switches through the same loom as I did my motors, my high current motors. And I said that wasn't a good idea because those signals are sensitive and you can throw false positives. And just like I bumped that limit switch, it can do it on its own if there's a bad enough interference. So a fix to this is to ground all the motors together. And you can see a temporary clip right there on that bolt that's holding the motor in. I've got it tied in ghetto style to the metal on the controller. And then these wires go up to the other 2 motors. You can see there's a clip there. And let me make you sick and fly you over the top here. And there's another clip there. But anyway, by doing that, it gets rid of the interference and false positives. And when you think about this machine versus this machine, that makes sense. This one doesn't have that problem because it's all aluminum, and so there's natural grounds for earth ground for the motors. Whereas this, it's hooked to wood in a lot of places, and there's no physical connection, say, between this motor and that motor. But having these wires just on the studs of the casing of the motor, taking it down to the case, fixed the problem completely. So I'll make up some proper earth grounds for that. But if you're having that problem where you're throwing false positives, Make sure that you're earth grounded on all 3 or 4, whatever you have of your motors. Yep, that'll fix it. There's one more setting I want to make you aware of, and that's this debounce interval. I've got it set for 100, and its default is 0. I was having trouble with the homing switches not wanting to act as stops as well. It would be one or the other. So I added 100 in there for a little timeout, and that did the trick. This is talked about in the Mach 3 manual, but it can be easily missed. So if you're having trouble with the limit and home switches doing what you expect, check this. And of course make sure that your motors are grounded like I talked about earlier. So yeah, I'm drawing about 60 watts right now, and I've got motor reduction on to half when they're idle for more than 10 seconds, and that's a feature with Hobby CNC's board. And I've got those jumpers set to give me the idle reduction, and that'll keep the motors from getting warm when they're sitting idle again for more than 10 seconds. This cycle's just about done, so I wanted to watch this power meter set in watts and see if it goes down after 10. Sounds like it's just about finished. Okay, it's stopped. Let's see what happens here. Look at that, jump down to 29 watts. And you could actually hear the stepper motors. So that's a really great feature. Now, you might be able to run with that, or you might be able to disable it for certain, like the Z. If you have constant pressure on this, it might want to move down on its own if you don't hold enough torque. But it's still 50% torque, so idle reduction, look it up, it's a pretty good feature. And how hot do the motors get? Well, this is an idle motor, and it's 107 degrees Fahrenheit in some places. Let's check this one. So you can see that's pretty hot for an idle motor running at 50% current. Let's run the motors a while, and then I'll check them again. So about 120 or so, it's been running a few minutes. So they do get pretty hot, but I've noticed they get hotter when they're just sitting idle. And that's why the idle selection for reduction is a good thing. They get much hotter just sitting idle than running, I think, if they're allowed to sit at full power. I've been playing with my limit and home switches, and I think I have them set up and ready to go. Let me show you the settings for that. So as you look down through here, you can see that I'm using 10, 11, and 12 as my pin number, and everything on the X plus, X minus, and X home are all using pin 10. So they're sharing the pin, and then 11 is for the Y, and the Z is 12. And they're all active low. And let me show you how it works. Okay, I'm going to demonstrate how the home switches work. Let me come up here to my Mach 3 and press the reference all button. The Z is moving upward. It's going to touch that switch and back off. Now that's zeroed. Now the Y is traveling. Let's take a look at it. You can see my switch under there. So it's going towards the switch. It'll do the same thing. Hit the switch and then back off it and then set that to 0. And then the last one is my X. There. And if you look up here on my DRO, my machine coordinates are zeroed. Everything's zeroed. And this is where you would start using the machine. Now that it's homed, these same switches become limit switches, so I can't go any further. There's also something known as soft limit switches, and that's where the software stops you from going beyond the extents of the machine. That'll be something we'll talk about later. So now I'll show you how that same switch can stop me from traveling too far and ruining my machine. Let's travel towards the X. My soft limits are off. Bam. Emergency condition. So now I have to back off this switch before I can go any further. Like I said, soft limits also allow you to stop travel motion, but this is like a last line of defense. So the switches serve two purposes. They limit travel, and they can be used as home switches. Soft limits allow your software to monitor if you're going too far to your extents. And that's one of the first things that you should set up when you're setting up Mach 3. You can see that for the X, I can travel a maximum of 14.65 inches to the plus or 0 to the minus. With the Y, I can go 30.6 maximum travel or 0 in the negative direction. And the Z is a little bit different. You notice that the maximum is 0, and that's because the stroke is at the top. If you have a router, the top of stroke is considered 0, and then as you're plunging into the wood, that's a negative number. So my maximum is 0, and then my stroke is minus 5.25. Pretty important that you set these up, these soft limits. And then this auto 0 right here is useful for when you're homing. The DROs will automatically 0, so you want to make sure those are all checked. I'm now homing the machine to the micro switches, and once that's done, I'm going to show you the soft limits that we'd set up in the previous screen. Okay, it's now done. When you use soft limits, the software actually prevents you from going too far, much like your switches, your travel limits. So you have two lines of defense of driving the machine too far. And you know you're in soft limits and you're using them when that green button right there is checked. It says soft limits. So let me demonstrate soft limits to you. So I've went ahead and I've homed my machine to my homing switches, and soft limits are active. And that's the first line of defense so you don't drive your machine into the side of your machine. You know, you'll keep it out of the way of going too far. So as I jog, everything's fine. Now let me go the other way on the X. As I'm approaching the end of travel, it slows down, and soft limits doesn't allow me to go too far. And I can show you with the Z as well. Let's go back up. And the Y will do that as well. So as it approaches the end of stroke, it slows down so you can't go too far. So that's the first line of defense of going, avoiding going too far. And then the micro switches will activate if something happens with the soft switches or it gets turned off or something like that. That's what soft switches is all about. It's a pretty neat feature. So I hope you liked this video. We got pretty far today with setting up the machine, and I hope I explained some of the features, especially with the homing and limit switches. And there's more to do, but I want to push it in place and begin using it. And I'm going to also make a video at some point when it's running really well of how to exactly set up Mach 3 from the beginning. But keep in mind, I want to make sure this is running perfectly before I do that. So far, so good. So anyway, hope you enjoyed the video. Leave me your comments below. I like reading them. Let me know what I should do differently or what I shouldn't do. And don't forget to give us one of these. It helps out a lot. We'll see you on the next one. Bye for now.